This video is here to help you with square roots and perfect squares. So let's talk about some of the basics of square roots. What is 5 squared? 5 squared is 25. Why? Because 5 times 5 is 25. You multiply 5 by itself twice. And then 6 squared. 6 squared is 36. Why? Because 6 times 6 is 36. So these two numbers, 25 and 36, the answers that we get, these are called perfect squares. Okay. So whenever we do a square root is the opposite of squaring. So instead of doing 5 squared and you get 25, this is the other way around. If you do the square root of 25, that gives you 5. And same thing, if you do the square root of 36, that gives you 6. So when we go to do square roots, we always want them to be perfect squares because our perfect squares come out to be nice, even whole numbers. Sometimes they won't be, but that's what simplifying is going to help you with in the rest of this video. Okay, so now that we have the basics, let's list a few perfect squares. So 1 times 1 is 1. 2 times 2, 4. 3 times 3, 9. It's a perfect square. 4 times 4, 16. 5 times 5, 25. 6 times 6, 36. 7 times 7, 49. 8 times 8, 64. 9 times 9, 81. 10 times 10 is 100. We're going to go up to 15. 11 times 11 is 121. 12 times 12 is 144. 13 times 13, 169. 14 times 14, 196, and 15 times 15 is 255. So what we're going to be doing today is we're going to be simplifying square roots. So if I gave you the square root of 16, you can do that in your head. We should know by now that the square root of 16 is 4, so that one is done. We simplified completely. If I asked you the square root of 121, that is a perfect square. It goes in evenly, so the square root of 121 is 11. Now, what if I asked you the square root of 50? Is 50 a perfect square? So do I see 50 up here on my list? No, I don't. 50 is not a perfect square. It's going to be in between these numbers somehow. Okay, so that's what we have to refresh our memory on. Do you remember how to break down a radical that's not a perfect square? So let's do it. So we need to change 50 to two numbers that multiply to 50. So what we're going to do is we're going to make our t-chart for 50. So we have 1 and 50, listing all the factors. 2 and 25. 3 doesn't work. 4 doesn't work. 5 times 10. And that's it. So now you are going to ask yourself, out of all of these pairs, which pair has a perfect square in it? So which pair has a perfect square? When we look, oh, it's this pair right here. It's 2 and 25. 25 is now a perfect square. So what I'm going to do is I'm going to legally change 50 to 25 times 2. I'm allowed to do that because it's the same number, right? Just replacing it with 25 times 2. So the whole point in doing that is because 25 is now a perfect square. My 25 can cancel. What is the square root of 25? It's 5. So that gets pulled out to be a whole number. And then what number is left underneath the radical? It's just that number 2. So my final answer is 5 times radical 2. And that's as far as simplified as I can go. Okay, so let's do another example. We have the square root of 32. So when I look at my numbers up here, it's obviously not a perfect square. So I'm going to have to list all my factors of 32 first. So when I do my t-chart, we have 1 and 32, 2 and 16, 4 and 8. So out of all my factors, which pair has a perfect square in it? 4 is a perfect square, but 16 is also a perfect square. So when something like this happens and you have two perfect squares in your t-chart, you always, always, always have to choose the largest perfect square. So you want to choose the 16 and the 2. Always choose the largest so that it simplifies completely. Okay, so we're going to legally change 32 to 16 times 2. The whole point in doing that is because now 16 is a perfect square, so that can cancel. And the square root of 16 is the number 4, so that just becomes the whole number 4 that gets pulled out front. And then what's left under the radical, it's just that 2 that just comes down. So my answer is 4 times radical 2. Okay, I just want to do one more for you guys. Square root of 63. Okay, so again, 63 is not on our list of perfect squares. So let's make a T-chart to list our factors of 63. 1 and 63, 2 doesn't work. 3 and 21. 7 and 9. So those are all of our factors of 63. So we are going to figure out which pair has a perfect square. There it is. It's 9. 7 times 9. 9 is our perfect square. So we're going to replace 63 with 9 times 7. The whole point in doing that is because my 9 can cancel. The square root of 9 is the number 3. And then what is left under the radical? It's just that 7. And my answer is 3 radical 7. So hopefully this will help you complete the rest of this form.